Welcome all of you to this video. In the previous video, we studied about composition and properties of matter. Let us now study the states of matter in this video. Oh wow! Preparations for someone's birthday are going on here. Let's see what items are kept here. Here, some sweets and juice is kept for the guests. And the room is decorated with balloons. Do you know what is special about all these things? All these matters are in different states. The piece of sweet is solid matter. The juice filled in the jug is a liquid substance. And the air filled in the balloons is a gaseous substance. Now you may be thinking that how can we find the states of matter? The states of matter are due to the different characteristics of its particles. Let us now study in detail the properties of the three states of matter. First of all, we will study solid state. Collect these items: square copper plate, brick ball and stone. Now, draw the shape of all these objects with a pencil on a paper. Do all these items have definite shape and clear boundaries? All these things are in solid state of matter. Therefore, we can say that solids have definite shapes and distinct boundaries. Now, if we look at their volume, we will find that the volumes of all these matter are constant. That is, there is negligible compressibility. Now, let's do a fun activity. Try hitting these objects with a hammer, dragging or dropping them. What do you see? Have their shape changed? No. Solids retain their shape even when exerted externally. Concrete can break when applied with pressure, but it is difficult to change their shape. Therefore, they are rigid. Why so? This is because there is very little free space between particles in solid matter, and the attraction between those particles is the highest. Can you tell whether solids diffuse among themselves? Let's find this out through a fun experiment. For this experiment, we will need a paper and a ball. Now, try to mix this ball with the paper. What do you see? These two solids cannot diffuse into each other. We have seen that the shape of solids are constant and the volumes are fixed. The attraction between their particles is highest. That is why the compressibility of a solid is negligible, and two solids do not diffuse into each other. Now, let us see the liquid state of matter. Like solid matter, is the shape of matter stable and fixed even in the liquid state? Let's find this out by an activity. There are three different sizes of glass utensils. There is a juice in this jug. At the moment, we can see that the juice has taken the shape of a jug. Now we will pour this juice in these glass pots one by one. What do you see? Yes, the juice changed its shape every time. This means the shape of the matter is not fixed in the liquid state. Is the volume of juice changing from one vessel to another? No. Therefore, we can say that in a liquid state, the volume of a matter remains fixed. Does the juice flow easily when poured from the jug into the glass utensils? Yes, this means that in a liquid state, the matter is not rigid, but it is fluid. Let us now look at these liquid objects: ink and water solution, sugar and water solution, and aerated drinks. All these matter are in liquid state. The ink and water solution is formed by dissolving one liquid into another. A solution of sugar and water is formed by dispersing a solid into a liquid. And aerated drinks are made by dispersing a gaseous matter into a liquid. By this activity, we can conclude that diffusion of solids, liquids and gases into liquids is possible. You may be thinking, but why? This is possible because the particles of matter move freely in the liquid state, and the particles of the liquid also have more space than the solid. We have seen that the shape of liquids are not fixed, but their volumes are fixed. The attraction between the particles of liquid is less than that of solid because the particles of liquid have more space. That is why compressibility of liquid is possible. In a liquid state, the matter is not rigid, but it is fluid. And diffusion of solid, liquid and gas is possible in liquid. Now finally, we will learn about the gaseous state. You know that all living beings breathe for their existence. Gases present in the atmosphere, especially oxygen and carbon dioxide, are essential for animals and plants. Do these gases have any shape or volume fixed? No. Therefore, we can say that matter in gaseous state have no shape or fixed volume. Now, let's do an activity. Take 3 syringes of 100 ml and close their ends with rubber cork. Remove all the syringe pistons and now let air in the first syringe. Fill water in the second syringe and a piece of chalk in the third. Now try to compress all 3 pistons by putting them in syringes. What did you see? You can see that first piston was the most easily suppressed. From this activity, we can conclude that gases have a much higher compressibility than solids and liquids. The large volume of the gas can be compressed into a low volume cylinder due to its high compressibility and can be easily sent from one place to another. This compressibility is possible because the attraction between particles of matter in the gaseous state is minimal. Friends, how does the aroma of the food being prepared in the kitchen reach us without entering in the kitchen? The smell of food mixes in the air and spreads from the kitchen to reach us. This is possible because of high speed of particles and large space between them. Gases show the property of diffusing very fast into other gases. So friends, as we have seen that the shape and volume of gaseous matter are not fixed, the attraction between particles of gaseous matter is less than that of solid and liquid, as particles of gaseous matter have more space. Therefore, the compressibility of gaseous matter is much higher than that of solids and liquids. Even in the gaseous state, the substance is not a rigid, but a fluid. And diffusion of gases into other gases is very intense. We hope that you have got a good understanding of the states of matter now. In the next video, we will learn about the effect of temperature and pressure changes on substances.